So the differential mode amplifier looks a lot more complicated than the inverter mode amplifier, primarily because you've got more resistors. So instead of just having one resistor at the inverting input, you've got a resistor going into the non-inverting input as well. You've also got an additional resistor down here of R3. So 4 resistors in total, whereas previously we're only really looking at 2. Still performing the same operation as other amplifiers, in that it's increasing some kind of input voltage and giving you an output, but instead of just having one input voltage that we are increasing, we've got 2 input voltages here, which makes things a bit more complicated. From the experiment that we just did, we find that V out is equal to RF over R1 times V2 minus V1. So what it is really amplifying, we've still got this same term here, those 2 resistors, that feedback resistor, remember that it's fed back from the output to the input, and we've got R1, it's the combination of these resistors again that is determining what the gain is. But what we're really amplifying is the voltage difference, so the difference in voltage between V2 here and V1. So it's amplifying the difference in the voltage. So what we end up with is a differential mode. So differential is really just a fancy word for difference. So if we look at what this means for our input voltages, V out will be negative if V1 is greater than V2. You can just see that simply from this equation. So if this value V1 is bigger than V2, then we're going to end up with a negative output. If V out is positive, then it means that V2 is greater than V1. Now there is one condition for all of this. And that is that it only applies if RF over R1 is equal to R3 over R2. So if you look back to your experiment, then both of these resistors here are the same. That's what that equation really says, is that R3 and R2 are the same, and R1 and RF are the same. So the ratio needs to be identical in order for this equation to work. So it's a slightly different equation from the one we've looked at previously. We've still got this term, this RF over R1 term, but we've now got V2 minus V1 because we've got 2 input voltages. So what the differential mode amplifier does is, instead of inverting the input like the inverting mode amplifier does, it amplifies the difference. So if that difference is negative, then it makes it negative. It doesn't change the sign at all. It's all to do with the difference between these 2 voltages. So if we then go on to look at an example, we've just talked about how this condition is satisfied. The ratio of the feedback resistor to input resistor 1 is the same as R3 is to R2. That means that we can then use this equation in order to calculate the gain. As I said, you're never going to encounter a situation where that condition isn't satisfied, but you now know that that is a condition of that particular equation. So we're looking to calculate V out, which is over here. What is our output voltage when we've got these 2 input voltages of 1.4 and 1.2? So it's RF over R1 equals V2 minus multiplied by V2 minus V1. So this part's easy enough to do. 200 over 5, they're both in kilo ohms, so we won't bother multiplying them out. Where a lot of people make a mistake is here in choosing which one is V2 and which one is V1. Think back to the inverting amplifier, and you know that this is V1. V1 is to the top resistor here. So if you know that that is V1, then you can figure out that this one is V2, or V2 is the one that is further down, which isn't as memorable a way to remember it. So it's 1.2 minus 1.4 multiplied by 200 over 5, so that's 40 times negative 0.2 So you get V out as negative 8 volts. So what that operational amplifier has done is amplify the difference in the voltage. So the difference in the voltage, because V1 is greater than V2, is negative. The difference is negative, so that negative voltage then gets multiplied by a certain factor. How big that factor is depends upon the values of RF and R1. So here it's 40, the factor is 40, so 40 times that negative 0.2 gives us that negative 8, and that's how the differential amplifier works.